Hello everyone, welcome to our project presentation for Milkmax production. In this first part, we will demonstrate the tools and techniques we use to analyze the production data and uncover actionable insights. Our team utilized Excel extensively for data reprocessing, analysis, and visualization. Let's dive deep into the data exploration process. Now I'll hand over to Jaspreet, who will walk you through our data processing in Excel. Over to you, Jaspreet.
Yes. In Excel, we begin by importing the data set collected from Statics Canada. First, we checked for missing values, which were crucial for ensuring the integrity of our analysis. As seen here, there were no missing entries in any column. Next, we generated summary statics such as the mean, median, and standard deviation to understand the data distribution. You can see a quick overview here of total production and key variables like standard milk and skim milk. Over to Pravina.
Mm, my part is the regression analysis in Excel. Using Excel's inbuilt data analysis tool, we perform regression analysis to determine how fluid purpose and industrial purpose commodities influence the total production. Here are the steps. First, we define the independent variable as the total production and separated independent variable into fluid purpose and industrial purpose commodities. And then we ran regression model for each group and recorded metrics such as R squared, mean absolute error, and mean squared error. The regression output for fluid purpose commodities showed a R square value of 0.99, indicating that 99% of variance in total production is explained by these variables. And for the industrial purpose commodities, the R squared value was 0.49 with a moderate influence. Regression output table in Excel highlight all the key metrics. Finally, Roy will explain how we visualized the findings in Excel.
Thank you, Praveena. To effectively communicate our findings, we used Excel to create visuals that highlight key relationship within the data. Scatter plots were used to explore the relationship between individual production variables and total production. For instance, the scatter plot for milk 2% versus total production showed a strong positive correlation, confirming its significant contribution to overall output. Correlation metrics were also generated a correlation metrics to measure the strength of the relationship between variables. This matrix provided a detailed overview of how different commodities interacted. For example, it revealed a strong positive correlation between skim milk and milk 1%, while highlighting the weaker or even negative correlation, such as relationship between sour milk and total production. These visuals allow to validate the regression assumption and supported the identification of key predictors. These scatter plots were particularly helpful in identifying linear trends and outliers, ensuring accuracy to our analysis. The correlation metrics, on the other hand, embedded us to understand which commodities positively or negatively influence our production. Over to Anjal.
All right. Now we will move on to our second part, which is the presentation. I'm going to share my slide. My screen is visible, right?
Yes.
Yes.
Right. Now let's move on to the second part of our presentation, Milkmax production. Our company's name is Milkmax Production. Milkmax Production is one of Canada's leading dairy company, which we have taken and we have done an extensive analysis on the different types of milk production and utilization for the company. And our objectives initially, our main objectives were to analyze the profits and losses and how different types of milk in which were sold at the highest rate and all. So now Jaspreet will explain about the methodology clearly. Over to you, Jaspreet.
Yeah. So we categorize the data into fluid purpose and industrial purpose commodities, and we used regression analysis as our primary tool. The dependent variable was total production, while independent variables were grouped into two categories, and assumptions of linearity and multicollinearity were tested and ensuring model validity. Let's now explore the results.
For the result part, our analysis revealed significant insights. The fluid purpose model explained 99% of production variance, with milk 2% and skim milk being the strongest predictors. The industrial purpose model explained 49% variance, with cereal cream having a positive influence, while whipping and sour cream showed negative coefficient. These findings highlight the reliability of fluid purpose commodities in driving production. And last is the discussion and recommendation part. Over to Roy.
Thank you, Pravina. Based on our findings, we recommend prioritizing fluid purpose commodities like milk 2% and skim milk for production, planning, and marketing. For industrial commodities, we suggest reducing production for whipping and sour cream and exploring new market strategies to boost our demand. Additionally, forecasting models should be utilized for inventory management and resource allocation. Over to Anjal for conclusion.
In conclusion, regression analysis proved invaluable for identifying key production drivers and inefficiencies in the company. Moving forward, Milkmax can enhance operations by integrating advanced analytics and market research. And hereby I conclude my presentation. I hope everything is clear right now. Thank you.